Okay, so welcome, and today we're going to look at the section of exponents. I think it's very critical that if you're in grade 8, you start learning exponents and mastering them from grade 8, because they just keep on increasing and getting slightly more challenging across the different grades. But if you know the basics and the rules, then you will do very well later on. As you will see in some of my maths classes, I'm going to take you back to grade 0, grade 1, 2, 3, 4, so that we learn the basics, because the rules are the same. I sometimes like to compare maths to law. If you know the law, then you can work out the sum. So as you will see throughout my math series, I'm not doing anything digital. I'm using a normal paper. I'm sitting on the same desk that you sit on in class. But one thing I would like to encourage you to do is to use different color pens, especially if you don't understand something. So you'll see in another lesson that I'll do, where I'm doing the basics you learn in primary school, like of long addition, long divisions. Different colors come in very handy to make the sum easy for you. So when it comes to exponents, but before I explain exponents, I think it's critical that some people are scared when you speak about x and the letters and what we call variables in maths. So if someone says x plus x, the easiest way to think about it is go back to grade 1 when they taught you 1 plus 1. So there was one item, you added it to another item, and then you had 2 items. So that's 2. So, but when this changes to x plus x, people get it wrong because they don't know how to work out the variables. But if you think about it, if I had a car and then I added it to another car, what would you then have? And then you see, I just saw someone answer there. No, it's not one car. Now you've got 2. But then you need to add what you have. So it's 2 cars. It's not just the number 2. If you give the answer 2, it's wrong in the sense that you've forgotten what items we're speaking about. So you have to mention it's 2 cars. So if you were to add x to an x, then you'd have 2x. Okay, but now let's get on to the exponents. So it was very important for me to explain that. And then as we go along, I'll also explain what integers are. So what whole numbers are, what natural numbers are. So I'll just give you a quick run through in this lesson what those are, but there'll be another lesson where I'll focus on those. So natural numbers start from 1, 2, 3, going in the positive direction on the number line. And then whole numbers add a 0. So natural numbers start from 1, whole numbers add a 0. And then we have integers. Integers include negative numbers, of course, going to infinity. But we'll deal with that. It's important that I mention them because sometimes we have negative numbers in exponents. And remember, exponents, in essence, are saying, let's say you had a multiplied by a, multiplied by a, multiplied by a. So 4 times. So exponents are an easier way of writing this. So what you are doing is multiplying the letter by itself 4 times. A multiplied by A, multiplied by A, multiplied by A. So basically, this is A multiplied by itself 4 times. So that's the simple matter of what exponents are. So if you had x, for example, multiplied by x 3 times. So that means you're multiplying x by itself 3 times. So that's the simplicity of what exponents are. I would also like to give you some advice, please. There are common numbers that are always used in different exams, especially in grade 8. Like, for example, 2 squared is a very favorite one. So you must know what 2 multiplied by 2 is, which is 4. And then 3 squared as well, which is 3 multiplied by 3, which is 9. And then also learn the cubed part of it. So cube means you're multiplying the number by itself 3 times. Squared multiplied by itself twice. So squared would be 2 times 2. You multiply the same number by itself twice. Cubed means you're multiplying the same number by itself 3 times. So 2 multiplied by 2 is 4. 4 multiplied by 2 is then 8. So you must learn the cubed. So 2 squared and 2 to the power of 3. So please learn all those all the way through, because those might come in your exam. And yeah, so let's do a few examples. So let's say they gave you 3 multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3, multiplied by 3. So that's 3 multiplied by itself 6 times. And if they told you to write it in exponential form, first the base is 3 because they're all the same. 1, 2, 3, 4, 5, 6 to the power of 6. And you know, another exciting thing that we're going to be doing in this series of maths classes, which I want to make different from other classes, we're going to walk on the road, call random people, and show that we can teach them how to do maths in like 10 minutes. When you are dividing, and then you have the same base. So let's say you had a to the power of 5 divided by a to the power of 2. Remember, the law says if the base is the same, so the variables must look the same. So it's a, and then the top one is raised to 5, the bottom one is to 2. Then you subtract. So it would be a to the 5 minus 2, which becomes a to the 3. I hope you're getting that. Yeah, so just look at that on the camera. And then another rule. So we're dealing with the rules first. So if you're multiplying, and then the base is the same. So a to the raised to 5 multiplied by a raised to 2. If it's multiplication and the bases are the same, then you just add the exponents. So it would be a to the 5 plus 2, which is a to the 7. I know that this is slow for some people who really get these things and do very well, but I have to start in the beginning to help those who struggle with this section. Okay, and then another rule says, anything, any variable raised to the power of 0 will always just simply be 1. So even if you were to take 100 and raise it to 0, and sometimes they like to put this in the exam and give it like 1 mark to just catch you out. Anything to the power of 0 is just 1. So 100 to the power of 0 is 1. Okay, and then we move on. Anything to the power of 1 is that number or that variable. So if it's a to the 1, then you just leave it as a. So if it's 10 to the 1, then you just leave it as 10. Yeah, so just look at that rule there. Maths and laws, eh? By the way, I'm reminding you, I'm not a maths teacher. I'm just some guy on the street who likes helping young people. Yeah, so we continue. 6. Now, when something is in a bracket, and I'll show you a bit of board maths now because it's important, the order of things that you follow. So if something is in brackets, so let's say a plus m to the power of n. Okay, before we do that one, I'll come back to it. So if something is in brackets, let's say a is raised to the power of n, then you practically just simply say that variable is raised to that power. So that means when you've got 2 different variables raised to the n outside of brackets, then each of those variables must then be raised to that power. So it would be a to the n and then m to the n. Each of the different variables within the brackets would then need to take that power. And then, so to come back to the one I started with, now I'm going to use different colors so you understand. So if it was a to the 5, for example, raised to n, then you would say you would multiply the exponent. So it would be a to the 5 multiplied by n. So here, when it's in brackets, we multiply. But remember, earlier when it was outside of brackets, then, and the bases are the same, then we add. Okay, please watch this video at least maybe 2 more times so you get those laws that I just explained. So now when we go do examples, you'll understand. Okay, so now I'm going to take an example from grade 8, which sometimes would look complicated, but it's not. So yeah, I hope you're learning. And then let's do some more tricky examples. So let's say, I hope this can work like on a page. So a squared. Okay, I'm going to ask the camera people to do this afterwards. I want to see if like they picked something up. Yeah. Yeah, and thanks to the donation of their time to be assisting. Before they're about to become famous, so at least I used them before. Divided by a squared, b squared, over, I think I need bigger paper. It's not going to fit. CD squared. Excuse me, maybe I'm supposed to be a doctor because my handwriting, it's not paper with it. Okay, let me put the brackets in blue. So when you see this and you're in grade 8, it looks very difficult. But it comes back to breaking down using the rules that we use. There's nothing to this. It's just variables. Variables are the letters raised to some exponents. So the first thing we need to do here, there's a division sign. Now, if you remember from fractions, you'll know that to get rid of the division sign, we must cross multiply. So we change it to a multiplication sign. So basically, this would then now become a squared bc over c to the power 3 d. Then we change the division sign to multiplication. But once you change it to multiplication, the things on the right now must flip. So what's at the bottom must come to the top. What's at the top must come to the bottom. So your CD squared goes to the top, and then at the bottom we have a squared b squared. And then now, because it's multiplication, then we can just multiply the top line and then multiply the bottom line. Yeah, we need bigger paper, brethren. Okay, I'm going to try and merge these two. So at the top now we have, and remember, we have to multiply this by all the variables inside. So it would be a squared b c multiplied by c squared d squared over c to the 3 d multiplied by a squared b squared. So we have to first sort out the top line. So in the top line, we look for things that look the same. So variables that look the same. So a squared is the only one. There's no other a at the top. And then, do we have another b? No, we don't. So b is alone. Aha, but now we have c. So since this c has nothing written on it, it always means that it's raised to 1. Remember that anything raised to 1 is that variable itself. So we have c to the 1. And then on the other side, we've got c squared. So we have literally c to the 1 multiplied by c squared. Remember, now we go back to laws. The law says if the variables are the same and it's multiplication, then we add the exponents. So c to the 1 plus c to the 2 becomes, okay, I'm going back to the other pen, becomes c to the 3. And then d is the only one, so it's d squared. And then we go to the bottom and look for ones that are the same. So we've got c to the 3. There's no other d. There's no other a squared. And there's no other b. So it's b squared. Now we can start working it out. So remember, now that it's division, if the variables are the same, we subtract. So the first one is a. So we have a squared and a squared at the bottom. If you take a squared and subtract a squared, so it would be a to the 2, 2 minus 2, which means it's 0. So a squared and a squared cancel each other out. And then now we look at b. So b is to the 1. Remember, any variable that's just by itself, when raised to the power of 1, it's just that variable itself. So b to the 1, I'm doing this on the side so you get it, minus 2. The variables are the same, b and b, so we subtract. 1 minus 2 becomes b to the minus 1. You see, now we're using integers, which is important, why you need to understand integers, but I'll do a lesson on that so you get it. And then we come to c. c to the 3 minus 3. Those cancel each other out. So c goes. Now we're left with d. So d, we have d to the power of 2 minus 1. Remember, when the variables are the same, we subtract the exponents. And here there's a 1. So d to the 2 minus 1 becomes d to the 1. So now we've got b to the negative 1, d to the 1. And remember, we can't just leave them as negative numbers. So anything raised to a negative number means that to make it positive, you put 1 over it, and then it goes to the bottom. That's another exponential law. So b to the power of 1, and then we leave the d where it is. So that's your answer. 1 over b multiplied by d. You could leave it like this, but I mean, if they want you to take it, leave it without any negative numbers, then you have to put that over 1. So remember, if anything is raised to a negative number, to make it positive, you put it under 1. I hope that makes sense, like mathematically, that you put it under 1. Although mathematicians would probably say over 1, but yeah. Okay, I hope you get that, so I'm just going to leave that here while you watch. And then in another, we'll go through many more examples so that you understand. But I was just trying to assist you to understand that this is not as complicated as it looks. You just need to break it down and make it look much more simpler. Yeah, so that's as difficult as you'd probably get in an exam somewhere. So we'll do more examples in another series. So I've just noted those down for you. And yeah, I trust that you get this better. I'll give more examples, and please do put your comments and let me know what you think. Oh gosh, I hope you're not bored. How long was that?